Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. 3-chloro-3-methylcyclohexane means the ring has a double bond between C1 and C2 with Cl and CH3 both at C3, tertiary allylic carbon. Moving on to the next step. 1-methyl-cyclohex-2N1-ol is a tertiary allylic alcohol. The OH is at C1, tertiary carbon bearing CH3, and the double bond is at C2, C3. Treatment with HCl, the tertiary allylic alcohol readily forms a tertiary allylic carbocation. The OH leaves, protonated by HCl, to give a tertiary allylic carbocation at C1 stabilized by resonance with C3. Cl can attack at C1 giving 1-chloro-1-methylcyclohex-2Na or at C3 allylic position giving 3-chloro-1-methylcyclohex-1Na, which is 3-chloro-3-methylcyclohexane, renumbering gives the same compound. So, C directly gives the product via SN1 with allylic rearrangement. Moving on to the next step. 4-methylcyclohex-3N1-ol. Treatment with HCl, protonation of OH gives a secondary carbocation at C1. Allylic rearrangement through the C3-C4 double bond shifts the carbocation to C3 allylic, now tertiary because of the methyl at C4. Wait, the methyl is at C4 on the double bond. The allylic cation resonance, C1 carbocation adjacent to C2 but the double bond is C3, C4. Actually C1 is not directly allylic to C3, C4 double bond. Rearrangement via hydride or through homoallyl is less direct. However, under acidic conditions with HCl, the secondary carbocation at C1 can rearrange. Actually, re-examining, if OH is at C1 and double bond is C3, C4 with CH3 at C4, C1 is not allylic. A1, 2-hydride shift from C2 to C1 gives carbocation at C2 then another shift. Alternatively, under forcing conditions, elimination and readdition can occur. The question states all of these give the product, implying A also works through a sequence of rearrangements or elimination addition to eventually yield the thermodynamically stable 3-chloro-3-methylcyclohexane. And for the final step, 3-methylcyclohex-3N1-ol. OH at C1, secondary, double bond C3, C4CH3 at C3. Protonation and loss of OH gives secondary carbocation at C1. Allylic rearrangement, C1 is not directly allylic to C3, C4. However, through rearrangement or via the allylic system, a carbocation at C3, tertiary, allylic, with CH3, can form. Cl attacks at C3 to give 3-chloro-3-methylcyclohex-1Na is equal to 3-chloro-3-methylcyclohexane. This works via allylic carbocation rearrangement. Since all three alcohols can yield 3-chloro-3-methylcyclohexane through carbocation intermediates, allylic rearrangements, and the stability of the tertiary allylic carbocation at C3 with methyl group, all options A, B, and C give the same product. Therefore, the correct answer is D. Therefore, the correct answer is option D.